Sure. And we have the pleasure of having Carol White here to do an overview of the results of the groundwater study that many of you participated in. She has lots of things to share with us, some suggestions, and I'm gonna let her introduce herself because she is gonna give us a good overview of her background. So here you go. I got your own. That's really good. Just the
My name is Carol White. I'm a hydrogeologist, which means I study the groundwater, both groundwater underneath the surface of the earth and work on things like wells, water supplies, contamination problems that affect the water that's underneath the ground and also the surface water. And I've been working in Maine for about 40 years. I live out on Street Island and kind of in a similar type of community to you folks. And I worked on some of these studies at the beginning of my career, so now it's kind of fitting that I'm working on them again at the tail end of my career, so I get sort of the double whammy here. But Bob Gerber, who I worked with early on, has done a number of groundwater studies in coastal communities in Maine, and you folks were one of the first towns in the community resilience partnership to do an update and kind of a revisit of the groundwater study that was initially done by Bob. And so things have changed a little bit since Bob did his study, but also things have stayed the same somewhat too, certainly in terms of our understanding of groundwater. So I'm going to go through some slides that I put together based on the study that we did. And the study was funded and I will say, I was here in this room on September 5th, 2024. So it's almost exactly. So the Community Resilience Partnership was developed here in the state of Maine to help communities improve their resiliency to climate change. And in this particular project, it was the Westport Conservation Commission that applied for and received a grant to do this project. And like I said, you guys were one of the first communities to do so. And the grant was on the order of $50,000, and we used that money to do well survey and to try to get a sort of think of it as like a checkup on your groundwater aquifer that you use in the water supply. So it's like when you go to the doctor and they check some of your vitals. We were checking some of your vital signs and also trying to get a better, more up-to-date database on the conditions here in Westport. And before we call this a groundwater sustainability study, and I just wanted to kind of set the stage with what we mean when we say sustainability. And this is sort of the most general definition, but I think it's the easiest to understand. And because the people use that word sustainability kind of, across the board, but when you're talking about groundwater sustainability, it really relates to the development and use of groundwater in a manner that it can be maintained for an indefinite amount of time without causing unacceptable environmental, economic, or social consequences. So I think we can all think of areas of the country here in the United States where groundwater is not being used sustainably and groundwater supply is being negatively impacted by the amount of withdrawal. Here in Maine, we normally don't have major problems at this point with sustainability in terms of the amount of use versus the amount of supply, but certain parts of the country, particularly the Southwest and California, is a pretty big issue. So, and someone asked me to put the slide from the last time I presented, and it's really, the term aquifer is very confusing to a lot of people, and I sort of forget that because I use it all the time. But there's lots of definitions for what an aquifer is, and I actually put two up here just to give you kind of a flavor for what we mean when we say aquifer. But aquifer refers to sort of the material in the ground, geologic formation, or a group of formations, and formations are rock type or soil type, or that contains sufficient saturated oil, so the water has to be able to move through it to be considered an aquifer. And then to yield quantities of water to wells and springs. And then a slightly different take on the same definition, and they use the term a body of rock, but it actually can be overburdened with soil that is sufficiently permeable to conduct groundwater and to yield economically significant quantities of water to wells and springs. So that definition brings in the concept of it has to be reasonably, feasible to extract that for water supplies. So you can think of the very taking soils that you see, so the clays that you see around the salt marsh areas, those would not really constitute aquifers. They contain water, they have permeability, but it's very difficult to pull water out of there in sufficient quantities that you could use for a water supply. So those would not be an aquifer. But sand and gravel deposits that you see around and bedrock extraction is an aquifer. So the other thing that is important to understand is that Westport Island is what's called a sole source aquifer. I used to be kind of a snob, so I started working for you guys because Westport Island, you don't take a ferry to get to your island, like I do. So I was like, but you guys from a groundwater standpoint, you're an island. So you don't, your water does not come from the mainland of the, along the coast. You are basically a self-contained groundwater aquifer, and all the water that you guys use, it comes in the form of precipitation onto the island. So although you're connected by, by the road, you're not connected hydrogeologically. So you are in fact still back in the 90s. Most of the islands in the, sort of Penobscot Bay area were designated sole source aquifers. They applied to the Environmental Protection Agency, who designates sole source aquifers. And so Wyoming and North Haven Isles were all officially were designated. And it's still an option. Communities still can be designated as sole source aquifers. There's several on the West Coast. And then you can see from that map in the middle of the, Martha's Vineyard, Nantucket, and some of the other islands are, and inland areas, Cape Cod is actually considered a sole source aquifer. The designation does not really provide any more protection. It's really just a recognition that this is your primary source of drinking water. And technically, to meet the definition, only half of your drinking water has to come from the aquifer, but for you guys, it's 100%, just like it is where I live on Shabby Island. So, it may be that there would be a time when being a sole source aquifer might carry some protections, but at the federal level right now, it doesn't really. And before I go any further, can everybody hear me? All right. So you may have heard of the concept of the water cycle. So that's really just the idea that it's all a continuous cycle, basically, say starting off with precipitation in the form of rainfall, snow, whatever. It lands on the ground surface. It will be, it will go into the ground, flow off on the surface, into the ocean, some will evaporate, some will transpire, will be drawn out through plants, and then ultimately go back into the atmosphere. And it's this continuous cycle that's known as the water cycle, driven in part by the heat of the sun. And so there's no new water being generated on the Earth's surface. So it is pretty important to think of the entire Earth as being a sole source aquifer, because there's no water coming from anywhere else. So this is just a sort of a snapshot of seeing the picture, and I just wanted to introduce the different concepts. So precipitation is rainfall or snowfall, or basically that falls onto the surface of the land or ocean. And what goes into the ground is called infiltration, or you might have heard the term percolation. And then what flows off on the, that's right, Dennis gave me this handy dandy pointer here, so. So what flows off of the surface is called surface runoff, or sometimes just runoff. What infiltrates into the ground might flow through the shallow surface or go further deeper into the ground. Some of it discharges and some of it goes all the way out and ultimately towards the ocean. Heat from the sun drives evaporation in the ocean, in lakes, in rivers, but also even on the land surface. Plants take up water through their root systems and transpire it back into the atmosphere, condenses into clouds, and then ultimately follows the same cycle. So that's what happens here on Westport Island is, this water cycle. So put it in perspective, generally here in Maine, we estimate about 50 to 60% of the precipitation that falls on the ground runs off into surface water and, water bodies and into the ocean. About 30 or 40% is either evaporates or transpires from vegetation, and then anywhere from 0 to 20% infiltrates or percolates into the ground. And things like asphalt and impervious surfaces, really there is no infiltration. So you may have heard the term low impact development. What that refers to is trying to minimize the amount of impervious surface so more or infiltration can occur and prevent runoff. And here on Westport Island, based on our average annual rainfall, we estimate that the recharge is anywhere from 250 to 300 million gallons per year. So it's a lot. So the things that affect how much water gets back into the ground, one of the primary things are the materials that are on the surface, the soils or the superficial deposits, what we call the overburden materials. And as you can imagine, very, granular, gravelly materials will allow a lot more water through as opposed to clays and silts where really there isn't as much infiltration of the water, more of it will run off. And then the bedrock surface itself, sometimes you have exposed bedrock, and in that, we really don't know how to quantify how much water gets on the bedrock, kind of intuitively we think it's not, but it's not easy to measure that. And when Bob Berger did his study back, I'm trying to remember, 2001, so when he did his study, he mapped the soils and used that as a way to estimate the amount of recharge getting into the aquifer. And he used only the surface soils, and these were mapped by the Soil Conservation Service, mostly for agricultural purposes, and then he used their classifications and sort of transformed them into recharge characteristics. And he basically classified them, with these different colors, based on how much infiltration they received. And that was kind of the state of the practice at that time. Since that time, the United States Geological Survey and other researchers have developed slightly more sophisticated tools to estimate recharge, where they take the vegetation, the slope, and the land surface characteristics into account in addition to just the soil types. And this is a gridded map that they produce that depicts the recharge here on Westport Island. And the yellowish colors are about a 5% recharge rate up to the really dark blue is about 20. You can see that it is approximately in that range, but the northern peninsula, sort of the north tip of the Westport Island in general, gets a little bit less recharge than the southern end. And the soils are a little bit thicker there, so that kind of makes sense. It doesn't exactly align with the recharge. You might remember that Bob identified recharge zones. They're somewhat coincident, but not exactly the same. But the thing about recharge, and if you've looked at the report at all or the story now, it's a very hard, parameter to quantify. And it's a big unknown, so it's kind of a big data gap for understanding our groundwater here in New England. And, the state is really thinking about it, trying to really come up with a methodology to try to help us quantify this number, because it kind of drives the whole concept of what you guys think of as carrying capacity or sustainable support. But, I will say that that's one of the challenges in this world of groundwater, is really coming up with an accurate number of how much water gets into the ground. So here on Westport Island, your primary aquifer is a bedrock aquifer. So you're dependent on the material that's some places exposed at the surface, but a lot of times it's under a little bit of overburden. And it's actually the cracks in the rock that act like little pipes that basically contain and store and transmit the water that you guys use in your wells. And over 90% of the people, it's probably closer to 95, of the residents that we have information from on their wells use drilled bedrock wells as their water supply. And for people in Maine who use wells as their water supply, that's about the average. So the majority of people using wells as a supply, except apparently for this building, use drilled bedrock wells. And so, as you can guess, and maybe you're aware in your own community that, you know, the number of fractures, the depth of the fractures, the orientation, and all affects how your well performs. And you're gonna have one well that's a great producer, not very far from a well that's not. And that's one of the idiosyncrasies of bedrock aquifers, as they're not as predictable as sort of sand gravel, granular aquifers that people use down in Hollis and, you know, some of the other areas of the state where they use these very extensive but kind of homogeneous aquifers. The aquifers here, bedrock aquifers, are very unique and vary quite a bit from place to place. So the type of the bedrock that you have and the degree of fracturing is what affects the amount of water that you can get out of your well, and which is called the well yield. And the minerals in the rock affect the natural water quality. So we can also impact our well water quality by things we do, but naturally, you might be aware, a lot of people are being elevated on manganese in their water supplies. It's very common along the coast of Maine to have high levels of iron and manganese. That's coming out of the minerals that are naturally in the bedrock. You may be aware that Maine has an arsenic problem in some areas where there's groundwater. That again is coming out of the rock minerals in general. So most of the time, there are certain types of constituents that are a health concern that are naturally occurring, that can occur in the groundwater. Iron and manganese generally are not a big health concern. They're really a problem for our fixtures and our laundry and that sort of taste, but they're not a major health concern. The average yield of a well in Maine is 5 gallons a minute, and as it happens, it's also about 5 gallons a minute here on Westport Island, the average. And that rotten egg smell, I don't know if anybody has experienced that, on a sulfide, or it's basically a sulfur smell. That's from the sulfide minerals, basically giving off sulfide gas in your water from the oxidation of those minerals. So that's just some pictures, sort of, you know, you can see the groundwater, that's Newfoundland, along the road cut on the highway, and the water's literally traveling out of that fracture and, you know, freezing as it exits. The other thing that's a concern, you know, as we think about climate change and sea level rise and saltwater intrusion. And so here is also a case where it's really when seawater gets into a crack that might, or a fracture that might daylight into your well, and that may cause you to bring in saline water that could degrade the water quality. It's very much a function of where you are, how many cracks intersect your well. Generally, the closer you get to the coast, the more, at risk you are, and the deeper you drill, the more at risk you are. So let's do that. I just put the slide in here to kind of remind me to just explain that, bedrock aquifers are very complex and they're not really well understood. We're kind of in, let's find a cure for cancer stage hydrogeologically. Like, we know a lot about them, but we don't know why some things happen and some things don't. And so they're a bit of an enigma, at least to me, and I've been studying them since I started, this work. But there's so many variables that it can be very hard to make general statements about bedrock aquifers from place to place. Because the number of there are just so many factors that can affect how they perform. And we do look at those factors as part of what we did in this analysis. And so the availability and even the vulnerability of the bedrock aquifers to contamination and climate change, is very local. So even in one town like Westport, one person might be very vulnerable to saltwater intrusion and their neighbor may not be. One person may be impacted by the contamination problem and another person may not be. So it's really a local problem, well to well. Sometimes we do see problems that form clusters and it can be related to the aquifer, to the, soil. But so far, it's difficult to characterize, and I just wanted to explain that, because it's not an exact science at this stage of the game. So and this is 2024, really, yeah, that's right. So the groundwater sustainability started in 2023 and we finished it up at the end of 2024. I think probably the primary driving, concern is really drinking water for all of us, so that we have adequate and, quality and quantity of drinking water for household water for our use. So the study that we did, and this was, particularly, Dennis and Dick here were, kind of spearheading the study, basically had three different, elements. The first was a data collection and compilation stage, that we did a well survey, then we did a water quality testing program, and then we took all that data and tried to compile it and into one kind of source. We took the historical data from the Gerber study, which was, I think I totally underestimated the amount of effort it took to kind of consolidate, get rid of, reduce and get rid of the redundancies, but in the end, we ended up with a comprehensive well database. We took some of the historical water quality data and combined that with the data that we obtained in 2023 and put it all together in one package. Then we took that information and updated the maps that had been made back in 2000 and 2001. And we evaluated kind of what the current conditions are, and then used that information to really look at how climate change might impact your groundwater aquifer in the future. And part of this study, which is partly why I'm here tonight, is really for the town to think about the best way to protect the groundwater that would work here for your community. So I did provide some sort of a menu of options that you could consider, from homeowner practices all the way up to what the town can do, and kind of some things, between, regulations, but also best practices to kind of education, and sort of kind of a spectrum of things that you can do. I hopefully will get into a little bit of that tonight. And then the other part that Westport did is the state of Maine has initiated a groundwater monitoring program across the coastal part of the state. And they are installing instrumentation that can kind of be read in real time for a saltwater monitoring network. And so we installed a couple instruments here in Westport that will be incorporated into that network in the long term. I will say, we're still troubleshooting one of the instruments as we speak, but there will be the capability for you guys to see how the groundwater is changing over time, you know, by logging into the computer and you can connect it to the town website. But it's still a little bit of a work in progress till we get it set up for the state. So we did a well survey back in 2023 and we provided it with the historical data. That information has been given to the Maine Geological Survey. They are in the process of incorporating it into, they have a statewide well database. So they are putting your information into that. And that would be a permanent repository, or when Dawn and I are gone, it will still be there. And we had kind of at least I had a moment of panic on this study because I knew the folks who had, so I knew someone who had data from her study, so I contacted her and she was like, oh, I just cleaned out my basement, I threw all that stuff away. So we thought we had no records of the well data, there were a couple hundred wells that were inventory back in 2000. But I don't remember who it was, somebody in this room found the old paper records and we were able to take those and basically incorporate them into the database. So that was a fortunate thing, but I think one of the things to consider and why we've given this data to the Maine Geological Survey is really, ways to keep this information both up to date, but, kind of secure for the future. And why do we collect well data? I sort of forget to emphasize why we do that. And it's the best information we can get on your particular bedrock aquifer. It gives us information about how much water you give out. It gives us information can give us information about how deep the soils are, what the bedrock is like in your area. And so it's really the best piece of information that we can get. And that's why we do these well surveys as part of these studies. Because to drill a single well can be $10,000 to $20,000. So if we have to go out and characterize your aquifer, it's cost prohibitive. And so we use the well data and that's why the state actually passed a law that all well drillers have to submit the data to the state. Not all of them comply, but that's the law, in order for them to compile that information, because it's a very valuable source of information about these particularly coastal aquifers, but all that. And so some of you may have filled out and participated in the survey, and that really made a difference. We had very good participation here in town. I think 260 surveys on that order. Here we go, 236. 98% of the people that reported, so this is the people in 2023 that reported information about their wells. 98% had drilled wells. About a third of them were from seasonal homeowners, the other were from year-round residents. A total of about 14% back in 2023 said that at some time in the past, their well had gone dry. And so that number might be worse right now. Approximately half the well owners reported that they had some form of treatment on their water supply. The majority of people were using iron and manganese or treating for iron and manganese, but people were treating for other constituents. And about 16% of the well owners said that they don't drink their water. So this is the well sampling program, and I learned a lot on this program, and I will say the other communities that are doing these studies have benefited from you guys were the first ones really in the Community Resilience Partnership Program to do a groundwater study. And, I think we didn't realize, I suspect that, and some of the other folks in this program didn't realize how much work it was gonna be to actually implement sampling. And I think we estimated it probably took, on the order of 300 volunteer hours, really for volunteers to actually, prepare all the stuff, to collect it back, to, make sure they correlated it with the homeowner, whichever homeowner was, to answer questions, to go out and sample. And so I think it was a very time-consuming effort, particularly on the conservation committee's part, but also a number of volunteers that also helped. But in delivering the samples to the lab, one of the challenging pieces of that sampling program is the bacteria samples have to be back to the lab within a day. And so we can't keep them for a couple days, and that means we really have to have a logistical plan to kind of get everything collected and back at the same time, but at the same time, we can't bring all the samples at once to the lab, so it was, it took a lot of choreography, and I will, kudos to the Conservation Commission, who really did a bang up job, and I will say, better than a lot of other communities. So it was good. And we tested, we got results back from 165 households. The testing was paid for by the dam, which was on the, the cost of that was about $9,000. And it took place over about 5 to 6 weeks in July and August, 2 years ago. And we analyzed every well for bacteria and fluoride, and then we did a subset of wells for iron and manganese because we know it's an issue out here. So what did we learn? And that's really what the point of the study was. So taking the well data that we received in 2023 and combining it with some of the Gerber data and some data that we had from the Maine Geological Survey, and then your code enforcement officer, I also collected some information, taking all of those data sets and putting it together. We have information on about 400 wells, which is excellent. That's a very good resource for the town. And I think we estimate that that's about 50% of the households here in Westport. And over 90% of those wells are drilled bedroom wells, and the rest of the houses use either well points or dug wells. I think some of that data is heavily weighted towards the historical data, so it might be that some people have replaced those systems for drill wells at this point. There's no alternative supplies for Westport, at least at the moment. You're not gonna get your water from Wiscasset or anyplace else. And so it's important that you take care of your water supply so that you will have it for the future. And then the other thing, we didn't focus a lot on septic systems in our work in this study. Other communities have been doing and focusing more on that and less on maybe water quality. But pretty much everybody here uses some form of septic system in Litchfield or wastewater treatment. Some people have what we call advanced systems or pre-treatment systems where they might not have optimal conditions, so they have to pre-treat their wastewater before they discharge it into the ground. So the drill well characteristics, and this is based on the 400 wells, the whole data set. The depth of drilled wells reportedly is 20 feet, is the minimum, but 700 feet, we had a report of a 700 foot well, and assuming that's correct. And then we figured what's the median value, and that was about 200 feet, which is pretty close to the state average. In terms of yield, we have several 0 gallons a minute, so some people drilled some wells that didn't produce. And then the highest yield that was reported is about 75, but on average, the yield, the median was 5. So, and 5 is plenty to support the average household. And, but there are a number of wells that are even less than that, but people can manage with extra storage or extra depth. The casing length here range from 0 to 100 feet, with the average being 20. The casing length used to be a good indicator of how thick the soil materials were, but nowadays, there's a minimum casing length of 20 feet, so that is not as good as it used to be, but that's part of the collecting that information.
Is that average or median?
Median, did I say average? Sorry. We use median a lot because the data is not that evenly distributed. So we did a lot of, I looked at a lot of the characteristics. I think there was work that these, linear features in the bedrock may correlate with higher yield wells. And we looked at that pretty closely, and really, I could not, statistically, we did some GIS analysis, and statistically, it didn't stand out that higher yields are near the larger than what we call minimums. So it's possible that that relationship exists, but based on the data that we have, we couldn't really discern anything. In general, you see sort of the northern part of the town, sort of where it narrows. The purple is slightly lower yield, and some of those brighter pink circles are higher yields. So I think you can sort of see that, yeah. So then on the water quality results, and this, the first part is the bacterial results, and that's a combination of 2001, 2005, and 2023. And, so we had 165 records for that, and about 80 of those had positive tests for total coliform, which is a general bacteria. And that was about 50% of the water supplies. I will tell you that that was almost every town I've worked in, it's about 50%. And so people aren't dying. So total coliform is a large class of bacteria. It occurs naturally in the environment. It was originally used in the 50s to 70s as an indicator bacteria that you might have a problem. Our ability to kind of identify the different types of bacteria and test for them has improved. And so now we can also simultaneously test for E. coli bacteria, which is the one we're really worried about. And that one is typically indication of some either it's fecal coliform, so it's bacteria from a gut of a mammal, and so it can be an indicator of septic contamination. That also can be from other types of mammal waste, you know, human waste, but mammalian waste. So it doesn't always correlate with septic systems, but it's often an indicator. And here on Westport, we had about 5% of the wells test positive for E. coli, which is not, which is not bad. And so that's on the lower end of what we're seeing in other coastal communities, so that's kind of good news. Then the other parameters that we tested for as part of the 2023 program are what we call organic parameters. The one that we're particularly interested in is fluoride, because that can be an indicator of saltwater intrusion. In general, the median value was about 14, which is pretty low, but the range was from about 5 to 1200, and 1200 is pretty high. And we had, I don't know, 8 or 10 wells that were above 100. So 1200 is probably salt water. I mean, it's definitely being impacted. 100 could be, I mean, it's maybe starting to happen. But we also saw some indication, I'll show you on one of the maps, that we might have some road stop issues. So it's not all necessarily shore front type saltwater intrusion, but can be application or storage of road salt. Iron and manganese, we have from non-detectable levels all the way up to 12 on iron, which is super high. And then on manganese, 1.2, which is also very high. Your water, most people with levels at that range would have to treat their water to really be able to use it effectively for subsing and even drinking. It has a metallic taste at that level. And then specific conductance was just another parameter that we use that's kind of an analog for chloride or just metal or ions in general. And so that was the range. 4,000 is pretty high. And that generally correlated with the elevated chloride, and that's what we were evaluating. And then arsenic, which is a health concern, and in some places in Maine, it's a serious health concern because it's naturally in people's water supplies. But here, we only did 10 samples this time, but we didn't detect any arsenic in any of the samples that we tested, so that's good. So these are just some of the maps that are in the report on the website. So this is the distribution of the E. coli contamination. And, it's kind of near the shore, on the north, on the south, it's sort of over many places on the island. So we didn't really see any particular correlation with that, but it's also not a widespread problem, it's pretty localized. Now, this is a map of the fluoride concentrations. The blue dots are the wells that are tested, but had low levels. The red are levels as they get bigger, there's higher levels of fluoride, so as they get bigger and darker, so the blue wells were tested, but no elevated levels, but sort of background. And the red is the areas where we did have elevated levels, so you can see there's a couple places where there are sort of clusters or a little bit more chloride. Basically on the northern part of town, and then on the southeast side, the elevated chloride where the star is actually inland. And so it's not limited to saltwater intrusion, it's probably, we think it's probably road salt, either road salt application or road salt storage. And there are chemical techniques that can be used to kind of differentiate the two, but that's where it stands right now. Then this map was, unfortunately, is low hard green. There is another version of it on the story map that's kind of interactive, and you can zoom in. But we were here looking at sea level rise and saltwater, the areas, how it would impact people's wells, and also areas that are experiencing saltwater intrusion. Fortunately, the areas, it's hard to tell on this map, but the areas that really have an issue with inundation during sea level rise are not typically areas that have pretty significant, just maybe that area there. But in general, we see more inundation from sea level rise is not necessarily correlated with your elevated saltwater intrusion wells right now. And so that, and we didn't see any significant number of wells that would be flooded by sea level rise. And this particular scenario, I believe, we sort of picked, I think it was 2120, I have to go back and look, but we didn't pick the very worst case scenario, sort of a more realistic scenario, I think. So, and that's one of the things we looked at. If you had wells that are already experiencing saltwater intrusion, and then they were also going to experience a significant amount of inundation from sea level rise, that would be a significant concern. There are some places in the state where that is the case, but it doesn't seem to be a big issue here. Then, so the last thing I wanted to cover in terms of the study that we did was that, as I think I mentioned, we installed some instrumentation here in town. Dick and Janice sort of inventoried potential sites, and we've installed 3 instruments or 2 instruments, and we've temporarily installed one here in town. They're basically measuring temperature, water level, and conductivity, which tells us if there's salt water in there. They actually send a signal with an antenna and are, through the cell signal cell network. Basically, that information goes to a company in Utah who then, compiles the data in real time, and we can log on the computer and look at the data. One of the instruments is malfunctioning right now, the other one has sort of a low battery because the cell signal seems to be an issue. So we're once we get those problems straightened out, we'll make sure that you can see those on the town website. You can see the data, but we want to kind of work out the bugs before we do that. And this will be incorporated into the major electrical survey saltwater monitoring network. So Jesse Meeks, who was here during the study and gave a talk to the community, is establishing a statewide network of monitoring. And we're using the same instrument. We're using some of the grant funds to help expand her network that she's installing here in Maine. And so these will go on in perpetuity through the Maine Geological Survey. And that's just sort of an example of what, what the instrumentation can look like. And yep, so that's, I guess, I'll leave it at that, and I think we can, if people have some questions, we can tackle those, and then, I guess I should sort of go on and say, so in terms of the quantity of groundwater, that's always the first question I get in the town is, what's our carrying capacity? How many houses can we build? How many people can we support? So it's not a simple thing to answer because the amount of recharge you get is really what dictates the availability of water. But using what we think is a pretty conservative analysis, you probably get 250 to 300 million gallons of water infiltrated into your aquifer. And then we did an analysis looking if every house was occupied, I think it was 540 homes, if those were occupied year round, so that includes seasonal residents being here year round. And using an average for a 2-person household, some would be less, some would be more. That turns out to be about 54 million gallons per year, which turns out to be about 15% of the total replenishment of your aquifer on an annual basis. So you're not over extracting your aquifer in terms of, I think conservatively you can say, you're not taking out more water than you're getting in. But that's not to say that there might be some places locally where wells are going dry because the conditions are such this time of year that their water table is low or their wells are shallow. So locally, there might be areas where people are experiencing problems, but on average, in town, looking at it from that standpoint, you're not using even 50% of the water that is being recharged to your aquifer. That we estimate is being recharged to your aquifer. But the other thing that's important to understand is that you take water into your household, you use it for drinking, you use it for washing, you use it for, flush the toilet. Approximately 90% of that water goes back into the ground through your septic system, through your leach field. So you're actually, recharging your aquifer with that water. So that is why we get pretty focused on septic systems is, maintaining and making sure the systems are properly sited and installed, because you want to be sure your septic system is doing its job, because it's replenishing your aquifer with water, and you want to be sure it's of adequate quality so that it doesn't follow up. And that's why we went around and tested for bacteria for that particular reason. Bob did the same thing, and I think he was in the same ballpark for what he had for findings. And so right now, today, we don't see evidence that there's a big problem with septic contamination. There are some areas that we did have problems, and some of them it took multiple times to really try to get rid of the bacteria, which suggests that, those wells might need some attention, or the septic systems might. But the town of Hartsville, for example, has areas where they have very high density of septic systems, and they have, those people have had persistent problems. They've had to install treatment and, UV treatment and other types of things, disinfection, because of that problem. So compared to other communities, not a huge problem, but it doesn't mean that if it's your well, it's not a problem. So, so there are cases of, kind of persistent coliform, and Jessica and I were talking about this, and I think, annual testing, if you're gonna do nothing else, testing your well annually for bacteria, just to make sure that that's not becoming an issue is worthwhile. But it's also important that you maintain your septic system, and that the town can help to play a role in that with the right education. Some towns have supportive programs for septic pumping, but so just think about it in your head. Yeah, we take out a lot of water, but we'll put most of it back in. And we want to be sure that it's adequately treated. So, and it's a good system. It's a clean system, low energy, passive kind of system. It's like, if people have come now in this day and age to really appreciate septic systems rather than sewage treatment plants that discharge through the ocean, which are extracting water from the aquifer, and it's going out, it's not going back in, at least not immediately. And a lot of those places have serious concerns about climate change relative to the outfalls of those treatment systems. So some of the southern Maine towns, many of them are really dealing with multi-million-dollar, $100 million projects to deal with their sewage treatment system. So, but if you live in the town of Yarmouth, for example, next to where I live, their water comes from wells in North Yarmouth and Yarmouth. But all of the sewage, most of the time, the sewer, all of that water is discharged to the Casco Bay after it's treated. So it's a very different type of scenario that we have here, or that we have in, you know, most of the island and coastal communities. So that's just an important feature. And then I did it in the report, and it's also, I guess I can go through these briefly and then answer questions, but in terms of sort of recommended actions. So bottom line is pretty healthy aquifer, good news. Will climate change affect your aquifer? Probably. Is it, do we have an area that looks like it's super vulnerable to sea level rise from a groundwater standpoint? No evidence at this point, based on the projections we see. Are there problems with coliform and saltwater? Yep, in a few specific locations. We don't have a lot of information on septic, so we can't really address that. But, in general, we don't see any major red flags. So, that's good news. But climate change up in itself, never mind development pressures, but climate change, I know, is, creating more rapid precipitation and more, extreme precipitation events. Temperatures rising, so we're experiencing, you know, more extreme precipitation events, which doesn't necessarily translate to more groundwater recharge, because when it rains very heavily, more of the water runs off. And so, even though our rainfall, our percentage of rainfall is increasing slightly, it doesn't necessarily translate to more groundwater recharge. And honestly, we don't know yet what that impact will be. Rising temperatures is generally not a good thing in terms of groundwater, because things like bacteria prefer warmer water, and, you know, things like that can cause more problems, and sea level rise again. So I think the other thing to say about all of these projections is that's what they are, the projections, and you know, sort of monitoring how your system responds over time is really the best way to figure out what's happening here. So to quickly go through, some of, you know, these recommendations. So these are all in the report, and if you would find the story map on the website that you will put a link to, you can find them there. And I put in kind of everything I could think of, because I think towns are different, and lots of towns, some towns want to do something, some towns don't. It's not, oops, sorry, it's not up to me to necessarily tell you what's best for your own town. You folks know, and you know what people are willing to do, and also what capacity you have. I think that's the other thing for small towns. It's like, what is your capacity to do something? So I highlighted the recommendation in terms of homeowners, maintain and pump your septic system, right? Because that's gonna protect your groundwater, your neighbor's groundwater, and the aquifer as a whole. We're finding that in some towns, as you know, seasonal rentals increase, and I don't think you guys are the worst case scenario. Georgetown has a lot of issues with this, but renters and tenants don't know what septic systems are. They don't know about wells, and they do all kinds of things they shouldn't do, including putting 20 people in the house at the same time. And so, you know, that thinking about how you can educate renters and tenants about well and septic use is worth considering. And there's some pretty good resources out there that are available, so it isn't like you have to create, but it's just probably distributing that. Then, you know, sort of common sense, but avoiding or reducing the amount of hazardous materials that could impact your groundwater, petroleum, pesticides, hazardous chemicals, PFAS. The less chance there is for your water to be impacted. And I worked for, you know, maybe 2 decades here in Maine, as we pulled out and replaced a lot of underground storage tanks. And the majority of them back in 1980 to 85 were leaking, and a lot of them have been replaced with much more, you know, structurally sound systems. But we spent a lot of time cleaning up petroleum contamination here in Maine. And so thinking about how you store both at your house, but even in the community, how you store hazardous materials, but reducing the amount of hazardous materials you use. And also thinking about anything that you use that goes down your drain is going into your septic system. So when I caught my contractor, when they poured the pavement or down the bathtub drain, I was like, hey, don't do that, but I don't think he ever thought about it, so anyway. Water conservation is a good practice, and in some parts of the country it's mandatory. Unfortunately, EPA's, water, sort of the water efficiency program has kind of been backburnered, but you can still buy, low flow fixtures and devices, so that used to be an incentive to do that, but now I think they're still available, they've been around long enough, but thinking about the amount of water you use, the less you lose, the less strain on your wastewater system, your septic system, and it's just a good practice. And if you've been to California or spent time in California, it's a totally different world out there in terms of how they use water. And then generally minimizing the impervious surfaces on your property. So if you have the choice of putting in porous pavement or asphalt as driveway, you might want to think about which one would make sense. And just the amount of land surface you cover with impervious material will locally limit your recharge. And if we all went on a billboard or a big song for each one, we really would diminish the amount of recharge. And in urban areas, it's a big problem. Here in Maine, we have a lot of still, open inventories, so it's not a big deal, but keep track over how much surface is generated in town, as they've done in some Maine communities, they have been keeping track, and it's, like the town of Brunswick's seen a 30% increase in the past 25 years, so it's pretty big. So municipal guidance is important. I'm not calling this like, regulations, but I think education programs and wells and septic for the community can, and it might be that the Conservation Commission takes that on as a role. There's, again, tons of information out there, I think it's really making sure the right people get the information. And then, creating a septic system, was what we didn't do as part of this study, that you may want to consider in the future is really doing the same kind of process for your septic system that you did for the wells, creating a very complete record that's geolocated of all the septic systems in town, how old they are, how big they are, how often they get pumped. Some towns are using it to kind of maintain a pumping frequency. They send out postcards like, remember, you need to pump your system this year. There's all different ways that you can use it, but even if you've ever looked for septic system data, the state has a repository that is the PDF files, but it's really not well indexed and it's hard to find. But as people replace or build new systems, you guys get the permits and you could scan those and then they could be located with the GIS. And I think that would be very useful both to kind of understanding how things change over time, but also to your code enforcement officer. So that's just something to think about.
Yeah, the other thing, this really came from the Maine Geological Survey, or has the well database for the state. There's a law that requires every well driller to submit the information, but not everybody does it. And so they recommended that you, as a town, could collect, and it couldn't be just voluntary, but maybe as we hand out the building permit, we hand out a well inventory form and ask the homeowner to fill that out, so that you get that information also. They said if you send that to them once a year, they'll make sure it gets in there. So it's like a redundant system to make sure that the well database stays up to date. And out on Tree, we just had about 8 wells drilled, and we did actually get the records directly from the well driller. They report them anyway, but we also collected them. But some of the well drillers are a little casual about reporting. Then there's, other things you can do relative to encouraging, really, it's the combination of maintaining wells and septic systems in a holistic relationship so that everything is working properly.
And some towns sponsor, subsidize, or coordinate the septic pumping programs. And so there's different ways you can approach that, but that's how some towns do it. And then periodic hazardous waste and pesticide and pharmaceutical collection, and right now, the state of Maine has a pesticide collection program in October. And so that's on the, and I can give that information to April, she can talk on the website, but they're collecting pesticides from homeowners, not commercial owners. And that's one way to get rid of them. Don't throw them in the trash. So this is sort of, another technique that, or another strategy that you could use to protect your groundwater is, to establish, that should be an ongoing water quality sampling program. There's different ways you could structure that. You could just recommend to homeowners that they test their wells regularly. The state of Maine has some guidance on how frequently you should test certain parameters. They recommend that you test bacteria every year. You could, I mean, there's different ways you could do it. You could just recommend it. Some, you could, what I've done much big is I kind of sponsor a day or a couple days where people can bring me their samples and they pay for them, but I just help coordinate it. So I just get them the bottles. It's kind of what you guys did on a smaller scale, but they actually pay for them. And then sometimes, like in other parts, particularly in Massachusetts, the towns pay for the sample. So I don't know that that's necessary here at this stage of the game, but it is, the state of Massachusetts does it down on the Cape, particularly because they want people to monitor their water quality, and they pay for it and they send it to the laboratory. So that's kind of the range that you can go through. And then the rest of these are sort of things that would be good to do, but we are participating already in the groundwater monitoring network. And then the other thing that's a bit of an unknown is actually water use. And so some, like, again, down on the Cape, they install water meters, digital water meters on people's wells, just so that they can truly measure how much water, because you can imagine it probably is pretty variable from house to house. And if somebody's watering a lawn or has a giant garden and, you know, doing a lot of even outdoor activity, that could translate to a lot more water use than, you know, someone who's just using it for cooking and washing and that sort of thing. So actually getting a handle, and it wouldn't necessarily have to be town-wide, you could actually just, you know, pick some representative homes just to get a handle on it. But that's another data point that we don't have the information on. In the western part of the US, on the islands out in the Pacific Northwest, a couple of those islands require monitoring as a sort of regulatory control. Where people are allocated a certain amount of water, their water rights are different out there, but this is on the San Juan Islands, and then they, if they go over that allocation, they get charged. I'm not recommending that. So again, this, you could go from asking people to submit their well information to requiring people to submit their well information as part of their building permit. And that's just, you know, that's just whether, how far you wanna go on that. It's not uncommon for subdivisions to require evidence of livable quantity and quality of water for a subdivision. Some towns require it for an occupancy permit, and that's sort of to protect the homeowner from themselves even. And, you guys actually have, I wrote 3 ordinances, and they're actually pretty good in terms of providing some of those features in your ordinances already. So somebody thought that through and added that kind of requirement to your, development ordinances, in particular the subdivision ordinance. So you're actually much further ahead than the majority of the towns of your size. You can consider being more protective about spacing of septic systems and, you know, septic systems from each other and from wells. The state requires a minimum distance of 100 feet. there is an opportunity to get a variance. I gotta say, I've seen a lot of problems when they granted variances, that people are experiencing well impacts from septic systems that are closer than 100 feet in some cases. Typically, they get a variance because they don't have a lot of space to put their septic system because the conditions are kind of suboptimal, like bedrock is near the surface. And so lots of times it's basically really a site limitation to begin with, and kind of getting a variance is not, it's not a gift, because it often turns around and become a problem. One thing Bob mentioned even way back in this study is you also could encourage people to install their wells further from the shore. The further away you're from the shore, the less chance you have for saltwater intrusion. And, you know, being more proactive about moving your wells further away is, you know, maybe advisable. And the last thing is, you have enough information as a community to apply, of course, sole source aquifer status through EPA, if that's something you're interested in. And then I didn't really put anything in here about ordinances. Like I said, your current ordinances are pretty comprehensive. But the one thing, or the one limitation, is that most of the development that occurs here, by my town, are single family homes. So those don't go through the planning board at the moment. And so that type of development is happening incrementally, and kind of finding a way to, for example, requiring potability for an occupancy permit could be something you could consider as an ordinance. That's kind of a big step, and I would be inclined to start with the simple things and really educating the community to understand how important their groundwater is the first step, so that everybody, if you do need to, or do feel compelled to adopt some, you know, more protective standards, the community is supportive and understands why. So, but the one, everybody, well, the planning board and probably some members of the community are probably familiar with LD 2003, which was a gift from the legislature a couple of years ago, which changed the density requirements, kind of jumped over local density requirements for accessory dwelling units. And it does require that the wastewater system can support the extra room, and the well has to be potable. But there's a lot of concern about how this might over time might impact communities like yours. And now they've also come up with some new ones, and they're even higher density. Some of them are restricted to just sewer, places with sewer and public water, so you may not see those. And those are just going through the process right now, but and we had a brief discussion with the state has a new office of community affairs, but it's sort of like the old state planning office, so they're trying to consolidate all the municipal related services into one agency to help towns like yours, you know, have a one-stop shop to get help. And so we met with the director, the geological survey, and I met with the director of that office. It's brand new. We're just staffing it up now. Some of the agencies are going to be moved into that. In fact, the community resilience partnership will come under that umbrella. One of the advantages is all the grant programs for municipalities will come through that agency. They'll all be in one place. But we had an initial conversation about, because I'm going town to town and everybody's worried about the water and everybody's got, you know, how do we do this? Well, I think this is really the role maybe for the state at some point. And I don't think necessarily that it should be, you know, sort of a restrictive kind of approach, but rather a recognition of the vulnerability of these aquifers, the importance of these aquifers. And I did find a study from back in like it was a coastal aquifer study that was done by Diane Grant Capital back in the late 80s. And it showed a lot of areas that were experiencing problems, which no surprise, they're having even more problems now. So there was a recognition way back almost 50 years ago that there are certain areas of the state that have, you know, limited limited water supplies because of their geology and hydrogeology. And I think that's maybe an approach that if a bunch of towns or communities got together, particularly in relation to something like LD 2003, where they're saying, you just have to do this. Well, I think communities like Westport and my community shouldn't have that dictated to us because we have different circumstances. We are a sole source applicant. And so we can't monkey that up. And we don't know all the consequences that could occur if we double or triple the density on people's lots. And it might take a while for some of those problems to show up. So that's just, I throw that out there because I think the legislative approach for all of these things could be more productive and easier than sort of global. So that's, I'm gonna stop right there. I meant to not go any longer than this, but I have time for questions and, happy to answer whatever questions you might have. I also would hope. So, I'll just open it up to questions and, let me just go ahead. We have some. Any questions? I talked to mom. Dick.
What would be the disadvantage of us becoming designated as a sole source aquifer?
I think there's no disadvantage, and I would recommend you considering that, maybe there are other towns kind of in the same boat, thinking, geez, maybe we should just do this. If we did it as a group, and the state supported it, the geological survey just started it for help with that. I think, and I think it might even have more benefit here in Maine than it might have at the federal level. There are no specific protections unless you had a federal project that was being proposed in your community that might impact the groundwater. So that is the protection. It hasn't typically. Designated as a sole source action. Yeah.
Couple of questions. One of is the study going to be continuing, meaning I can't tell you whether the home that I live in, had it one tested or any of that, had a sample, and I guess 50% were part of the sample, approximately a little less. Is it going to continue? Can we test our wells, whether we had our own sense of it's fair and be part of the data that you're collecting in order to help?
Yeah, and that's a good point that I heard mentioned. So certainly. You know, $20 or $100, but there is a laboratory right in Wisconsin that we use, and they have, you know, their tests are pretty affordable. It would be hugely beneficial to share that information, and we could incorporate it into the database. I think the town could also sponsor some well testing, whether they pay for it or not, but just coordinate it or make information available. I think that's up to the town to decide, but I think telling people what we should be testing at a minimum and, letting people know that, and then just providing information on testing, and, you know, I would think that's would be, as I said, I kind of highlighted that as a recommendation. Because it's kind of like your policy annual, you know, it's like a good idea, and that's how I think of it, is quality of the water in general around that. And if we start to see a trend, then that will be a concern.
Just one additional unrelated question, and that is, I saw your recommendation relative to education as it relates to tenants. There are quite a few places that rent in the summer. I guess some of the tenants might be educated, but quite honestly, they don't care. As a homeowner does, so would you have a stronger recommendation or a recommendation that would somehow apply to the owner and or the tenants in such a fashion that will actually work?
I I haven't really, I think probably you folks would know what might work here, but I think Georgetown, they told me they're having a lot of trouble with this. Too many people in a building at a time that's well beyond the capacity of the septic system. And that can be a problem, because then the system can become overwhelmed, and that can cause contamination problem. So I think they're, in their short-term rental ordinance, they're contemplating adding something about, they have some language in there. But I think, I think there isn't, unless you wanna provide some form of enforcement, that's a different track. So, I mean, I think there probably are parts of the country where they can do that, I mean. But I know in Georgetown, and they may have some suggestions, I'm working with that right now, and I know they have a really serious problem with rentals. They are concerned about the people who draw the wells dry, they do overwhelming septic systems, and they don't know what they're putting down there. And I think the first place to start though is education. It's inexpensive, and I think the majority of people would comply if they knew.
I think the owners comply, I don't think it depends.
I don't know, I mean, I tend to give people the benefit of the doubt, and,
Well,
yeah,
you've had that opportunity.
okay. Yes,
I'm not sure how all this works, but I'm just wondering if one well can draw like 750 gallons per minute and another well can draw 700. Is that well is drawing that at that rate, robbing them this other? I mean, should there be some way to reducing the amount of water that can run by reducing wells?
so wells can interfere with each other, or kind of overprint on each other, so basically you can get two wells close together, and if they both draw down, they'll affect each other. So I think that's what your question is, and if someone is using a lot of water and they impacted on the well, is that your question?
Well, I'm just wondering, in terms of like education, if a person thinks they've got plenty of water, and so they're not subconscious with it, and another, didn't think they need to know that they may be impacting their neighbors, and just make that part of the education. Don't use your, as much water as you get.
Right, so that sort of goes to the water conservation concept, and sort of thinking about your water use, how much you use, where it's going, and, kind of, try to minimize that, both with how you install fixtures in your house, but also just your general use. I think probably this time of year, the bigger concern that we see is people with water, and if you're, some places have already instituted people with public water supplies that are experiencing water bans, because the public supplies don't want to risk drawing down their supplies anymore. But you can't regulate that in locally if people are all on private wells, because the only way, it's basically the way water law works in Maine, it's each individual homeowner kind of manages their supply. It's not really, the law doesn't really protect people. You have to go to court under a civil suit under trespass if somebody's well, or, septic or somebody else. So we don't have optimal rules for that, and it's homeowner to homeowner. Because the wastewater system is gonna be installed to code, and is regulated by the state, the code enforcement officer can address a malfunctioning septic system, so that is a town role. On terms of the wells, a new well has to be installed up to code. And and actually newer septic systems have to dig like the, entrance now to the surface so that you can easily access the tank. That's a new change. And well, the type of well construction that's required now is for, robust than what was used historically. So people with older wells would potentially benefit. I just had somebody in Long Island where their casing was cut off right in the ground surface, and they had sort of a gasket style cap. And they were having a major bacteria problem when they disinfected. And so the well driller extended their casing and put a sanitary cap on the top. And so those kinds of things, but those are typically homeowner to homeowner kind of improvements. That's,
Yeah, could you describe the concept of the freshwater lens that occurs under an island community like we have, and what the dangers are of going too deep?
Yep.
Pretty well.
so. That's really, a good point, and I actually have a slide up there that showed that, but I didn't really go into it, so. And this really goes to the concept of sole source aquifer. I think this picture may. Yes.
Another picture, right?
That's right. Oops. So, what Dennis is talking about is the fact that saltwater is denser than freshwater. And so when you're on an island, the precipitation falls onto the surface and kind of forms this lens or bubble on the island and slowly discharges out into the ocean. But it basically floats on top of the salt water, the fresh water, because it has a lower density. And so and it moves up and down. And here on Westport, we really don't they know very well how these systems function in North Carolina, where it's a very sandy kind of environment. We're not really sure how they work here in fractured bedrock aquifers, but certainly, it's similar. It just may not be the same relationships. So basically, this is your fresh water, this is your salt water, and lots of times you get sort of a transition between the two. And as the water levels move up and down seasonally, this can be a mixing zone. But basically, the issue that I think Dennis is referring to is the angle right here of the interface between the salt water and the fresh water. If you drill down deeper into the aquifer right at the shore, you run the risk of intersecting the salt water. When you're in the middle of the aquifer, that risk is much lower, and you have a much greater depth that you would go, so you would theoretically run into salt water. And so that is sort of the issue when you're near the coast. You don't want to drill your wells too deep, because you're increasing your risk of intersecting groundwater, saving water. So that's another depiction of sort of the same idea. And the reason why someone's well might be salty and another one nearby might not be, could be merely the particular fractures that they intersect. But as a rule, going deeper and closer to the shore increases your risk because of the angle of the interface between the fresh water. So if you're out here, you can go deeper than if you're right here without intersecting salt. Does that make sense? Yeah.
If we're near the shore and we hydrofrac the well, does that significantly increase our chance of saltwater intrusion?
Well, I think the jury's out on that, and I will say Jessica Meeks, who's the hydrogeologist for the state, was here. And she doesn't think hydrofracking is advisable close to the shore for that reason. But I don't think the state's really tackled that idea yet, and I don't know that they have any evidence. I think it's possible that it could increase your risk of saltwater intrusion, but, it depends on kind of how they hydrofrack and how, really what the type of rock is. So. Yeah.
I'm just curious if the change in the wetland designation would and how to influence our water absorption. I mean, you can say that that's an issue.
So changing
Wetland designation is when it's land, we can't build on. So it's changed the last 3 years and it's not actionable for wetlands.
Carol, can you repeat the question just
Yeah.
on the
So,
recording?
yeah, so that question, I think if I understand it, was the areas that were previously unbuildable wetland areas are now being built upon or being
Or the
impacted.
yeah, the designation's changed in potential for building.
Yeah, so in general, wetlands are sort of discharge, areas of groundwater discharge. I think they're particularly important from an ecological and habitat standpoint, but they don't generally serve as groundwater recharge areas. We think of the recharge areas as being kind of more the central spine of the island and where groundwater infiltrates and then typically in a, but not all cases, but typically in a wet area, we're dealing with groundwater being very near the surface and potentially discharging. In some cases, little small vertical surface water bodies are really expressions of the water table coming above the surface and then disappear. But I think they're concerned, not so much for groundwater sort of recharge and supply, but they're concerned for habitat and groundwater protection and, you know, in general. Yep.
I'd like to check something, actually, I think you said if you 250, 300 million gallons of water a year kind of available to the island. Then you start to figure of either 15 or 50%
So,
is being used.
Yeah.
I don't know which end of it.
so, and this is like a super rough estimate because we're not, Bob, I will say this is where Bob and I, you know, depart. And it's sort of a, I just talked to Bob a couple weeks ago and I said, I'm gonna go to Westport and tell them what, you know, something different this last. But, the Bob did some modeling simulations in particular for Southern Maine where he tried to quantify that number, kind of absolutely. I don't think we can do that, and so that's my opinion. So I came up, just by the estimates on the average types of soils, I came up with an estimate of about 250 million gallons getting into the bedrock aquifer. Then if every household has 3 people in their household, it uses the average amount of water that the state says people use, which is 90 gallons per day per person. That translates to about 54 million gallons for the entire island for the year. So that is about 15% of the
15.
15% of what you get on, if I did my math correctly. And I,
Assumes everything's interconnected.
correct. Well, that, no, that's assumes, yeah, I guess you could put it that way. The other thing that's important to point out, especially today, is we also looked at what we call the drought scenario. So that assumes that we're only getting 60% of the typical rainfall that we get, and we have the deficit of, I don't know, it's more than 10% right now. So we have a pretty big rainfall deficit at the moment. So if you look at 60% of the average annual recharge, that's about 200, a little over 200 million gallons. And if you look at the same scenario that everybody's in their house year round, then the household water use would be about 25%. So during a drought, so the other thing that we have in coastal communities is we have maximum population during the least amount of recharge, and like right now, a drought condition. So we kind of have the greatest pressure on the system when it's getting the least amount of recharge or replenishment. So seasonally, this time of year, August and September is the most vulnerable in terms of sort of replenishment of the aquifer. So that's, you know, the other thing to keep in mind is your wastewater system is putting the majority of that water back into the ground. So. And so from that standpoint, wastewater, on-site wastewater systems are a good thing. Because they are replenishing your aquifer, so as long as they're well maintained, they're, you know, doing the storing their aquifer. Yeah.
So you're doing that based upon a median or average, but is there a way to localize those numbers so that it's not a median or average, so a particular, I don't know what the size of the area would be, has different numbers and therefore different risks?
Yeah, so like if a subdivision was being proposed, typically in many communities, and I think your ordinance could require it, we do a localized study, we put in specific wells to really, you know, kind of, quantify the amount of water that is available and look at the quality. you evaluate the amount of recharge that you're getting, and you typically use a groundwater model, but you use it locally, where the conditions locally are probably more uniform. But I will say, it's hard to do with a fractional background, but that's how it's done. And you could quantify that locally. The things that really help locally would be having very, believe it or not, precipitation can vary across an area, so. And what they do when it really matters is they install instrumentation to measure the amount of infiltration. They actually install lysimeters. Probably did have some experience with those. So to try to actually get handle on how much water is coming in. And then there are some techniques to use water level fluctuations to get a handle on the recharge. And then the other thing is sort of what the actual low interest is, because sometimes it's more, sometimes it's less. But if somebody was coming in with an operation that needed a large quantity, and the state of Maine would require them to do that kind of analysis. So it's not uncommon to do that, but people typically are not doing that unless it's a subdivision that meets the subdivision requirements. And if my memory serves me right, you can ask for a hydrologic study under your subdivision ordinance.
So take that one step further, I imagine that's even more difficult as it relates to a single residence development.
Yeah, but one way we did learn a lot about wells is when we dealt with a lot of these petroleum contamination problems. And even just by, like, if you're in a neighborhood, you can pump the wells to see if the other wells respond. So that tells you that they may be connected to the same cracks. So there are some things you can do that are pretty inexpensive and simple to try to get a handle on it. There's one area in Georgetown where they really have some pretty severe water intrusion, and I think they're looking at sort of trying to do a local study for that reason. Because they really want to try to figure out how to manage their water use, because they don't want it to get worse. Yep, yeah.
I just wanted to say, I know that you said there were at least $300 of volunteer work, which probably, yeah. But I just want you guys to know that Carol White also put in probably 100 more hours than she should have.
But you're my favorite town.
Yeah.
Just don't tell Shadeka. No, you guys have been a really fun town, and I will be happy to come back again when you get further down the track, but I think, this was why Bob and I had a conversation, I don't want this just to be a study that sits on a shelf or sits on the internet. I hope that you will take it and take some steps to do what you can and what you think is right to protect your water. And I think there's a lot of interest in the community, and I think people have, better than the rest of the state of Maine, people in these coastal kind of island communities have a good grasp on kind of the importance of groundwater. So I think you should, take that level of engagement and interest and try to use it to the town's advantage. So.